in Fort Lauderdale, and we're going to be talking about hurricane science, storm surges, the future of hurricane science, and what global warming is going to mean for all that. Let me first introduce our speakers. On my left is Sharon Majumdar. He's associate professor at the University of Miami's Rosenstiel School of Marine and Atmospheric Sciences. He has flown on hurricane hunter planes, and his research focuses on improving analysis and predictions of hurricanes and typhoons through the use of technology like satellites, drones, aircraft. He's published a lot of papers in scholarly journals. And next to him is Jesse Fyan. With NOAA. He's a scientist with the National Oceanic Atmospheric Administration. He is manager of their storm surge roadmap. He's been working on improving NOAA's storm surge products for the public, and because that's just been recognized as just an increasingly important aspect of hurricanes. And he also, well, everyone up here has a PhD, so, but he also has published a lot of papers in scholarly journals. And next to him is Ben Strauss. He is, I wrote down your title because I had to, Vice President for Climate Impacts at Climate Central, which is a nonprofit climate research and journalism organization. He has written a lot of scientific papers, and he's also been the architect of their surgingseas.org coastal flood risk tool, which is this thing you could look at on the internet to see whether your house is going to be flooded in a storm surge. And he's been interviewed on the press a lot. He's been on TV. He's testified in front of the Senate. So how we're going to do this, each speaker is going to get a maximum of 5 minutes for an opening statement, and I'll ask a couple of questions to get us started, but I'd like to have as much time as possible for questions from the audience. I'm sure you've heard the ground rules before. Everything's on the record, and as for audience questions, SEJ members first, and then everyone else. I can't see from here who has the SEJ tag, so it'll just have to be on the honor system. Anyway, so to begin, Sharon, you want to start?
Okay, thank you, David, and thanks to SEJ for having me here. So it's great to be in the audience. I'd like to make a few remarks just about some of the challenges and advances in the prediction of hurricanes. So it's first instructive to review how far we've come before moving on towards what the real key issue is. So the main progress over the last 2 decades has been in predicting the position or the track of the hurricane. So where is it going to go? And for example, the forecast of Hurricane Katrina and of Sandy, those were both excellent forecasts 2 days out. On average, there's been a really important gain in lead time in hurricane track forecasting. So by that, what I mean is that a 2-day forecast now is actually on average as good as a 1-day track forecast was 15 years ago. So really in the critical warning periods that were 4 day of lead time. This has also increased the confidence in being able to make forecasts out to 5 days, as the National Hurricane Center does. And they're also testing a 7-day forecast of the track in-house. Now, it's a different story when it comes to hurricane intensity. Now, the intensity is a really complicated quantity in itself. The intensity means that maximum sustained wind averaged over 1 minute anywhere in the hurricane. It's really related to small-scale processes, and what it means is that it can change very rapidly with time. And really the errors of intensity forecasts have pretty much stayed the same over the last 2 decades, even with all the improvements in technology. Although there have been some improvements over the last couple of years. It's been a concerted effort, particularly by NOAA and also other funding agencies, to improve intensity forecasts. There are also other aspects of forecasting that are necessary beyond just track intensity. So how big the hurricane is, what the extent of the, say, the gale force winds are, are, and then the impact forecasting. So, for example, forecasting storm surge, forecasting how high the water levels are going to be, predicting inland flooding. There's a lot of consequences of hurricanes where there are big challenges in the forecasting. So how do we address these? Well, it's mostly through improving computer models. So there's a range of global models which are kind of, they're very advanced models that can forecast at the same time, say, the rainfall in New Orleans and the temperature in Australia. But they come at a cost that the resolution is not too great. So it's a trade-off. For example, like we can't have really high-def resolution football stadiums, for example, on the big screens there. And so an improvement that has been made in the last decade or so is to build these what are called moving nests. They're high-resolution domains that follow the hurricane and simulate the hurricane at a very high resolution to try and simulate the eye wall. And that's really critical to the intensity prediction. Now, there's a lot of extra work that's needed in terms of improving the physics representation, those models. It's a really tough challenge right now. Some targets that have been set that are research targets include how to ingest aircraft data, such as radars that are mounted on aircraft, into those high-resolution models. And then I mentioned aircraft, and those aircraft right now are all the manned aircraft, the hurricane hunters. But also, just coming online are unmanned aircraft. So NASA has 2 Global Hawks. They're flying those this year. I'm involved in that field experiment, and feel free to ask me any questions about that. And so the Global Hawk can loiter over the hurricane, and it can release many little instruments into the hurricane. And it also has various sensors there, so it's kind of like a nearby satellite, for example. And then there are also low-level unmanned aircraft that would fly in the lowest areas of the hurricane, what's called the boundary layer, the lowest few hundred meters, and so they're also being tested. Right, and just a final comment that we're also looking into techniques to improve forecasts of the uncertainty of the hurricane, not just one forecast, but many forecasts at the same time to determine our confidence in the forecast.
Thanks. Jesse?
Thank you, David. Thank you for curating the panel here. I'm happy to be here in New Orleans. Obviously, I'm an area that's very familiar with the threat from storm surge. That's my area of expertise. I work in the National Ocean Service, but collaborate across NOAA and other federal agencies on the storm surge threat. So I had a sense that maybe there's a different or range of experience and knowledge about storm surge, so I figured the best place to start is sort of from the basics and then get into where we're going, both with the science and with our products and services in NOAA. From a tropical cyclone or from an extratropical cyclone, coastal flooding is often one of the biggest threats to life and property from a storm. However, we know that the public often doesn't really understand what this threat is, and that's one of the big challenges. So it's not just predicting what the surge will be, but it's also communicating that risk. And often the issue is that the public thinks primarily of the wind threat from a big event like a hurricane, and that may not be their biggest risk of loss. So what causes storm surge? Well, it's a combination of factors. Obviously, primarily it's the wind stress itself on the surface of the water, but it's also combined with the reduced atmospheric pressure, which actually raises the surface of the water under a tropical storm, for example. It's wave contributions that increase the setup of the water and also cause runoff. And then, of course, we can have precipitation and runoff that's contributing to flooding. And so understanding all those factors is important to making an accurate prediction. Those predictions and those water levels are very local because they're significantly impacted by local topography, and New Orleans is a great example of this, where the levee system and the canals and channels that exist around here, and this occurred during Katrina, really have a significant impact on what the local water level is, and what the local impact is, and what the loss can be. So it's very complex. The other factor that is very significant is actually the characteristics of the storm itself that's causing the event. So the strength of the storm, where it makes landfall, the size of the storm, all those sorts of factors have a significant influence on what the storm surge level will be. The speed, the length of time the winds are blowing, and one of the challenges in communicating what the event could do as it's to make landfall is to work in communicating with the public and helping them understand that this specific storm is different from storms that have occurred in the past. And that's one of the challenges when you're talking with the public is they may think of a historical storm, whether it might be a Betsy or a Camille or a Katrina. The next storm that's coming has its own unique characteristics, and it's important for them to understand it. Within NOAA, the role of NOAA is to really lead the operations and forecasting. That's led by the National Hurricane Center for Tropical Storms, their storm surge unit, and they rely on model predictions to do that. They use a couple of storm surge models in order to predict storm surge during those events. One of those is based upon SWASH. It's a model that's been used by the Weather Service for a long time. It's run in a probabilistic mode to deal with the uncertainty in the forecast. You're probably all familiar with the cone of uncertainty that occurs during a hurricane forecast. So we can't rely on just a single track prediction in order to predict a storm surge because there's uncertainty about the specifics of the meteorology, as I referred to earlier. So we actually take that track and create many permutations of that, and then using the SWASH model, it's a very efficient model. It does those calculations very quickly, so hundreds of tracks can be run, and probabilistic prediction can be generated. Now the challenge in dealing with probabilistic predictions is communicating probability to the public. So that's one of the big challenges. In order to improve our ability to communicate, this year is the first year that we put out a new product called the Potential Storm Surge Flooding Map. It's a graphical picture. You'll be familiar with this concept. It's a graphical picture of what areas are at potential risk of flooding from a storm and what the potential depth can be. So it shows, thank you. It shows the potential worst case scenario for that event, and so that's been one of the biggest. Thank you. That's been one of the biggest challenges in communicating to a wide variety of audiences, both technical public officials and the general public, is really understanding where the water is going to go. And so we did an extensive series of social science work in order to design this new product so we could understand actually how it's interpreted by the user and that they understand what the threat would be. Before I conclude, I would highlight that we are continuing to improve the models that are really driving these products. Okay, and I wanted to mention I have more information on that product up here. So if you'd like to grab one of these tip sheets afterwards, I'd be happy to share them with you and answer more questions. Thank you.
Thanks. Ben?
Thanks, David and SEJ, for having me. So I'm going to focus in my remarks on the influence of climate change on storm surge connected with hurricanes and other coastal storms. And the main points I guess I want to make 3 or 4 main points. One is that, and I'm going to look through the angle of sea level rise. Okay, I'll touch on projections for how hurricanes may change due to climate change, but one thing that we have a lot more confidence about is that sea levels have already risen and are continuing to rise, and therefore any given hurricane produces a higher surge. So the 3 points that I want to make are that we are already seeing and will continue to see more storm surges crossing critical thresholds, being extreme floods, causing extreme floods. Second point, every coastal flood today is already higher, larger, and more damaging because of historic sea level rise, and that trend will continue. And the third point is really, well, it's already here, and even just a few inches make a difference. I seem to be coming in and out every few seconds, so just bear with me. I'm wondering from the AV people if it would be easier if I just didn't use a microphone and used my stage projecting voice. Is that okay? I must use the microphone. Okay, so just bear with me. We have a wider audience. I'm going to...
Let's try this one. Sorry about this.
All right. Well, I think this link just doesn't work.
Nothing. It's not on.
Oh, is it not on? Is it?
How about that?
No.
Testing, testing. Okay, here we are again. So, I'll illustrate these points through a few different stories. Since I'm from New York, I'll start with Sandy. Later, I'll talk about Katrina. Sandy was, at its maximum, drove waters 9 feet above the high tide line at the Battery in Lower Manhattan. Over the last century, we've seen about 8 inches of global sea level rise driven by climate change. What difference could 8 inches of sea level rise make when the water was 9 feet above high tide line? Let me give you a back of the envelope calculation. 1 year before Sandy, Hurricane Irene pushed water about 5 feet, an inch or two shy of 5 feet above the high tide line at the Battery. It caused essentially no economic damage from coastal flooding in New York. So the difference between that 5-foot and 9-foot event, we know the difference in what happened. The vertical difference is 50 inches. 8 inches is 16% of the difference between a non-damaging flood and a very damaging flood. Also, damage from storm surge goes up more steeply than depth. For example, when the water gets to the level of an electrical outlet, damage level really jumps. So from this really crude calculation, I might estimate 15 to 20% greater economic damages in the real world, as opposed to an imaginary world where those 8 inches of sea level rise had never happened before Sandy. We took it a step further and did a little exercise with our kind of coastal mapping analysis based on very accurate elevation data, and we looked at what's in New York City below 9 feet versus what's in New York City below 8 feet, and we by 2/3, and we get, well, maybe Sandy exposed an extra 75,000 people and $9 billion of property. That's really also a kind of back-of-the-envelope calculation, but that's a significant difference in the extra fringe of flood. Sorry about that. And we're working on current research that does it the real rigorous way that suggests the back-of-the-envelope calculation was. Okay, so 8 inches can make a big difference. Katrina. I don't have a similar analysis for Katrina. However, yeah. So there was brilliant research done by a fellow named Aslak Grinstead, who, we have problems analyzing hurricane trends over time because our ability to observe them with satellites have changed. Grinstead looked at tide gauge records in the Gulf and Atlantic coasts of the US since 1923. He found that hurricanes have been increasing over time and that they're in particular associated with years. So I find this more powerful and persuasive than projections connected, pure projections based on computer models into the future. And in particular, he found that events are more than twice as likely in globally warm years than globally cool years. That's the last 100 years. Okay, so a Katrina grade event, more in terms of storm surge, more than twice as likely in a warm year than a cool year. And we have a trend of increasing surges and surge strength that we're already observing. So there we go.
This useless microphone, thanks. Okay, I'm going to ask a couple of questions to get us started. Take questions from the audience. Sharon, let me start with you. You were talking about how difficult it is to predict storm intensity. Can you explain, A, why intensity is important? I mean, compared to track, I would think track is much more important, but maybe and also just why it's more difficult to predict.
Okay. First up, the track is probably still the number one in terms of that. That's what we have to get right first. But then beyond that, it's important to predict the intensity for several different reasons. One is, for example, for wind damage, and so the wind speed, the wind structure, of course, is what then influences the wind damage. And then, of course, the wind speed is really important, as is the structure for storm surge prediction. So it's not really a case of either or, that it's more so that they're both concurrently very important to predict. The track has generally been relatively straightforward to predict because the larger scales of the atmosphere are easier to predict. So there's a lot of satellite data out there. The atmosphere moves slower at the larger scales. There's been a lot of effort that has gone into global modeling and using all of those satellite data and Hurricane Hunter data at the resolution that the global models run. And there's perhaps a higher inherent predictability for the track. Now, the intensity is a very different ball game, that it's really now looking at the inner workings of the hurricane itself. And it's really not that observable either, that there's just a few aircraft observations if we're lucky. The satellite observations are generally not quite as good in the hurricane and not quite at the resolution that we need to then really predict this very fast changing structure that then affects the intensity. So that's one reason why intensity prediction is really difficult. It's just a very fast-moving process within the hurricane itself, and it's very difficult to observe. And the physics are really complicated and needs a lot of work for the same reasons.
Thanks. Jesse, I want to ask about the storm surge mapping you've done. Can you just give us a general sense of what parts of the United States you found are most vulnerable and how this is likely to change with sea level rise?
Sure. So I think vulnerability is driven by two factors. One is low-lying topography, which if you've been on any of the tours this week, you've probably seen the reality of that. The other factor is the increased population growth at the coast. So I'm sure you all have taken a vacation at the beach and you've seen beautiful homes right on the water on a barrier island, or you've been to Miami or other places like New York City, where the infrastructure is closely intertwined with the local waterways. And historically, that has made a lot of sense because that's where sort of the economy is, the marine transportation is, but it also leads to a lot of vulnerability. So as when we were developing this map, we didn't want to put out a product that couldn't address any area that would be vulnerable from a tropical cyclone. So this new potential storm surge flooding map would be showing the potential for coastal inundation anywhere along the east and Gulf Coast that could be affected by a hurricane because of the importance in being able to address the risks there. And as sea level rises, I thought Ben described this very well, that risk is going to increase. So the previous session talked a little bit about this. There's a difference between what happens in an individual event to the long-term trends. But the long-term trends are just going to increase the risk that's there. Conversely, we need to be able to show what the threat is from any one particular storm. And so we want to understand sort of where we're going while also being able to clearly show what the threat is today and communicate that and make sure that people understand the risk that they do face.
And Ben, I want to ask you, in response to the storm surge mapping that NOAA's done, that you've done, what are we supposed to do in response to this? And are any parts of the country doing it right? Any parts doing it particularly wrong? Could you just talk about the reaction to that?
It's a good question. And it's a tough question in a way. I tend to keep my blinders focused on describing the as opposed to what we're doing about it, but I do learn about things that are happening around the nation. I think what Jesse said is right. Our momentum right now in terms of development is toward the coast and toward low-lying land. And over the long run, if we're going to want to minimize the pain, we're going to have to develop momentum away from the coast and away from low-lying areas. And I think, a lot of attention is paid to sea level rise projections and how high will sea level be in 2050 or 2100 and what happens when you add that to a storm surge. And if I'm the Army Corps or if I'm a city government and I'm thinking about building a new piece of infrastructure or facility, maybe I say, well, this thing is supposed to last for 50 years, so I'm going to look at the projection for 50 years, and if the projection isn't flooding my facility in 50 years, I'm okay. And what I think that does is ignores the fact, how much infrastructure renewal are we really doing these days? Right? Something built for 50 years, first of all, is usually made to stretch 100 years or longer. Second of all, it creates momentum. If you put a new train station there, other things will develop around that. So I think, on the one hand, we'll probably, we will certainly see over time. I can't tell you how much time. Years, decades, restrictions on what can be developed where. So saying no to development in certain low and risky places, reducing the possibilities for insurance or making them prohibitively expensive. But something else that can be done is, we might eventually see, is developing a momentum. When citing a project, realize that it has an influence that extends far beyond the kind of listed lifetime of the project, and will develop and will create its own momentum. And maybe we can create uphill momentum in our thinking about the future. And I think the places in the nation that are kind of thinking the most ahead in these respects are California, some Southeast Florida, there are a lot of people thinking about this in New England and Norfolk, some of the most affected places. But I also think the truth is that we are at the very, very dawn of really facing the issue of higher seas.
Okay, I'd like to open it up to the audience for questions. I'll ask again, SEJ members first, everyone else second. And if you could identify yourself before you ask the question. Yes, go ahead.
Jan Spiegel from the Connecticut Mirror, the other place that also got hit by Sandy. And Irene, this is kind of for Jesse and Ben. I'm wondering, your kind of back of the envelope calculations, as far as sea level rise, as far as storm surge goes, and how that might change in a semi-closed area like Long Island Sound, where you've got this narrow body of water and things sort of hit the sides and then reflect and then build. Is that sort of an area, and maybe the Chesapeake would be another, where this is going to get to be even more further exacerbated by that particular type of geography?
Okay. Jesse, you want to take that?
So the question is, I'm repeating the questions for the record. So the question is, does an semi-enclosed bay like Long Island Sound or Chesapeake Bay increase the vulnerability, perhaps, to coastal inundation events, both weather-generated and long-term risks? I think that, to me, that really goes back to the point I was making earlier, in that for any particular event, the impacts are local. And so we see one of the challenges in Long Island Sound is it has a significant tide range, which does interact with the water levels that are being raised by the weather event. And so one of the factors that was happening during Sandy was the uncertainty in the landfall time of the storm. And so some of the earlier forecasts had the storm making landfall later, which would have occurred with peak high tide in the western part of Long Island Sound, and really would have increased the flooding by several feet in that area, if not 5 feet. So it actually occurred during peak high tide in New York Harbor near the Battery, and so actually became an extremely high, on the order of like 1 in 2,000 year event for that area. So how I would address that issue is with some of the things we're already doing, which is developing models and systems that can account for all of those factors and really understand them when it comes down to a specific event. So we in NOAA have technology that tracks what the topography is, what the tides are from observations and models, what the datums are, vertical datums, all those things, what the wave conditions are, all those things are important in order to be able to predict impact and then communicate it. And then there's also analysis of what the long-term trends are from sea level change, which does vary along the coast. And so if you're a local stakeholder, you'd want to understand the combination of all those factors. I don't know, Ben, do you want to comment on that too?
Just very briefly, I'd say kind of in the time scale of weather, it is true that an enclosed body of water like Long Island Sound, with the wrong storm coming in the wrong direction, there can be an amplification of the surge. Same thing happened in New York Harbor with Sandy. You're squeezing water into a narrower area, okay? That effect is not as, so that's a very important risk and effect for any event in real time. I don't think it has a big interaction with long-term sea level rise. The long-term sea level rise will be more uniform on that spatial scale. And we are doing some more detailed analysis with Sandy, looking at Sandy as it happened and Sandy as it would have been if water level was a little lower, and with physical models. And the answer is not exactly the same as if you just subtracted 8 inches everywhere, but it's quite similar.
Yes, I'm Kimberly Blair with Pensacola News Journal, and we have the barrier islands that protect our main part, our peninsula, our main part of our town. And it's a barrier island that's been eroding dramatically, and there's plans to re-nourish it. So my question is, when you're taking these calculations about storm surge, is the elevation and level of a barrier island calculated in that in any way to figure out how bad that storm surge would be on our personal community? Or did y'all get that microphone that down?
Yeah, so I'm sure both Ben and I can answer this question because we're both dealing with predicting and mapping water levels in some of our work. Sorry, the question was, thanks, David. So the question was, does the height of a barrier island, for example, in Pensacola, is that taken into consideration when assessing the risk from coastal inundation? So yes, most definitely. So that goes back to one of the key factors about why the flooding is local. And so during storms, and you've had storms in your area, the wave height can erode a barrier island, and so it depends upon the wave height that occurs for that storm. It can overtop a dune, and that can increase the amount of inundation that occurs behind a barrier island. Understanding what we refer to that as the total water level from the event, understanding the combination of the tide, the surge, the wave heights, wave run-up. We're trying to improve our predictions to account for all those factors. The other important piece to that is having accurate elevation information. So coastal LiDAR data, which is collected from aircraft usually, is used to map what the elevations are along the coast, and getting up-to-date information about what the condition of the coast is very important in being able to predict the impacts for both storms and sea level rise changes.
How current is your data?
That really varies spatially. So then there's a lot of different agencies, both federal and local, state governments, county governments that collect that data. So that'd be hard to answer for any one place. There are national programs. The USGS has one that collects LiDAR data along the coast and along barrier islands in specific in order to understand those changes. But it is important that that data is collected as best possible.
Yes.
Hi, my name is Linda Morris. I'm a freelancer. I had a question about the relation of wetlands with the speed and intensity of storm surges, because, one of the things that I've read is that everybody has written that, not everybody, but I've read that, Katrina might not have been as bad as it was if there hadn't been the tremendous destruction of the wetlands, south of New Orleans. So maybe either Ben or Jesse or Sharon could address this.
The question is, how much do wetlands protect coastal communities from storm surge, and if so, how much? And I think the short answers are they do, but it takes a lot of wetland. They don't have a huge effect. I'm not an expert here. I'm connected to some research that's just getting started with a look at Jamaica Bay in New York. I think the answer will depend often on where you are, but I think it's a very serious issue here in Louisiana, where there are lots of wetlands that are disappearing quite rapidly. Because I don't remember the statistic, but it was something like you save X amount of storm surge per mile of wetland crossed. So just to get you in, so we're measuring wetland in miles there, and that's something you can do in Louisiana.
This is Jesse. I'll just comment briefly on that. In that, I think I would agree with what Ben said in that the function of the wetland is it reduces the wave height. It increases friction, but it can't absorb water necessarily. And so when you have a Katrina that's got 15, 20, 25 feet of water, it's much more significant than what the wetland is. So it really depends upon the characteristics of that storm and how significant that wetland role is going to play. It is important, but also what's happening during that event is another very important factor.
I don't know if you're ready for a non-SEJ or affiliate, whatever I am, but I work for the USGS and I'm in the Coastal Change Hazards group, and I just wanted to alert everybody that, number one, we just put out a Coastal Change Hazards portal, which is access to a lot of different kinds of information, historical shorelines, sea level rise, vulnerabilities. It's a really powerful assembly of data in one place. And the historical shoreline data, I wanted to just let everyone know that in some places shows no change, and that is actually a reflection of the fact that they're nourishing the beaches. So it is an extremely complicated topic. And following up on Sandy work, there's an awful lot of work, research being done to connect wetland relationship to destruction of barrier islands and sea level rise. And I look forward to sharing that with everyone. And if you're interested, just let me know. But you can get it on our USGS Marine Geology website.
USGS Marine Giant Geology.
If you Google Marine, USGS Marine, you should be able to find it.
Yes.
I'm Nick Alman, also with USGS. I'm an ecologist and working on Everglades stuff, but I just want to also caution you that the definition of wetlands is an important one. And when you say wetlands, different people might see different things. So wetland without woody vegetation, for example, in South Florida with mangroves, a person might call that a wetland, even though by definition it's not. But the mangroves have a tremendous potential for gardening. So, and the other thing to point out is that wetlands in general, even though we might be measuring miles and impact, we're getting to the point with sea level rise that even small changes can have serious consequences. So we shouldn't overlook that as well. So even though it might take miles to have a small impact in storm surge height, that can be a tremendous difference.
Yes.
Yeah, I'm John Tibbetts. I'm a South Carolina Sea Grant Consortium. I'm also a freelancer. And I'm wondering about the implications for flood insurance in some of these states. I understand that the elevation data is becoming much more precise, so people are finding out that their actual land elevation is 10 feet lower than it was before. And so now you get the storm surge data, maps that are going to be more precise. So flood rate maps might be going up and down. People coming in, being put out of the flood zone, and other people being put in. What are the implications of your research that might affect the flood insurance rate?
So the question was, what are the implications of the work that's being done on insurance rates, and maybe what's the interplay between insurance and factors pertaining to understanding what the threat from coastal inundation is. So that's not something we deal directly with at NOAA. That's obviously the FEMA runs the flood insurance program in the United States, but it is an important issue, and because of the local economic impacts, we have been engaging in NOAA with the insurance industry to understand to work with them to help understand what the threats are and how the science information that we provide, like the high-resolution topography that you were referring to, or the water level data that helps understand what the risk is, what the return period is for this type of event in that area, how that can be used in order to make insurance rates more accurate and more robust, and support how those decisions can be made. To me, a lot of that depends on really having high-quality data and sharing that amongst all the parties that can be impacted and the stakeholders that are affected by that. That's one of the main contributions that we're making from NOAA. I don't know, Ben, do you want to talk about that at all?
Sure. I think, one piece of this is that science is always evolving and improving, right? I mean, that's just a part of the process of science. We'll have better data over time. And every so often, the kind of policy process has to catch up with the latest science and kind of reset the clock. And FEMA is putting out a new generation of flood maps that I think reflect advances in both storm and surge modeling and also elevation data. They do not yet reflect projected sea level rise in the future, although FEMA now has permission to think about that, to incorporate that begin to incorporate that in their analysis, and I expect we might see that 5 years from now, or 10 years from now. I don't know where exactly. I can't give you precise directions, but I know FEMA and I think NOAA together did a project where they took the FEMA 100-year flood map for New York, New Jersey, Sandy affected area, and then they added a foot to it. And then they added 2 feet, and they published that online to just give some sense of future floodplains.
Hi, Robin Bradford from Greenwire. Professor Ron, I wondered if you could talk more about the drones. You said they were coming online. Are they already in use? Where are they being deployed? And what does that mean to understanding?
Right, there's been a series of... yeah, sorry, my bad. The question was about the unmanned aircraft and what stage they are at right now. Are they online or are they coming online in the future? And the broad answer to that is that with a spectrum of different unmanned aircraft, that they're at different stages of their development. So we could probably start with the high altitude and then work our way down to low altitude. So the highest altitudes, there are the Global Hawks, and NASA has bought 2 of those, and they've had a field experiment in each of the last 2 years, 2012, 2013. Then this year is the final year of their 3-year field program, where they're planning to sample, and indeed are sampling, several hurricanes. So that's at a relative stage of maturity in the sense that it's the 3rd year of the program. But since they're very new instruments that have been mounted aboard the Global Hawks, that there have been a few teething problems, particularly in 2012. In 2013, there were virtually no storms that could be sampled. So this year is a real crunch year. So many people are on edge a little and hoping that there would be some good cases to sample. The Global Hawks have flown Hurricane Cristobal last week. They flew 2 missions around that hurricane, and then over the next month they'll be able to sample some more. And the question still arises, and there needs to be a lot of science and analysis to be done about the value of those data in terms of advancing the science and the potential improvement to forecasts of the hurricane track, intensity, and formation. Now if we move down to the lowest altitudes, there are some much smaller, low-level unmanned aircraft that have been trialed a little in the 2000s. There were 2 Aeroson missions in 2005 and 2007 in the Atlantic, and then also there were some Aeroson missions in the Northwestern Pacific flying into typhoons. And those aircraft, that they're pretty small, you can pack them into a guitar box. They can be flown, they can be launched off the back of an SUV, and they're designed to fly in the boundary layer, that's the lowest layer of the hurricane, and collect some really valuable data that the manned aircraft and satellite are not able to sample. Now, there have been issues there with the FAA, particularly on the US shores, and so that program slowed down a little through that side, that the FAA said, well, we need to rework our regulations for the low-level unmanned aircraft. This year, and as part of some new funding post-Sandy, it's called Sandy Supplemental, that there's a new project in which some very small unmanned aircraft called Coyotes being launched out of the Hurricane Hunter aircraft. And so they're released, they're a little canister, and then they, as they plunge through the atmosphere, they open up their wings, and then the idea is that they are able to fly around in the lowest part of the hurricane. Now that's still under clear air testing mode, but that's a 2 to 3 year project plan for some of the low-level unmanned aircraft. And there's others that are under discussion and development in the Navy and at NOAA at the same time.
Thanks. Other questions? Yes. Oh, I'm sorry.
I just brought up to you because
What? Okay. Oh, University of Miami. Got it. Okay. Other questions? Yes.
So I just have a point, and then maybe Jesse, you can respond to this. The science, having been in this business a long time, the science.
I'm sorry. Could you identify yourself?
Oh, Brian Norcross from the Weather Channel. The science has improved dramatically. We know much better where the storms are going, and we know much better what who might be flooded. What hasn't changed really is the communications, our ability to communicate with people, because as the message gets bigger, getting a bottom line action message is more complicated. So, and I know I've talked to Jane Broom about this, and we've talked to Hurricane Center about it as well. But the 95% of Americans get their weather information from private sources. Right? But there's a move within NOAA, including the storm surge, to develop things that are on NOAA websites. Right? And I'm just wondering, in the development, to what degree are you really concentrating at this point on the science? And I know there's all the social science aspects of the colors and all of the math, but it feels like from a private industry standpoint, it feels more like perhaps you're working more on the science and getting it out on the NOAA sites as opposed to through the 95%, and how thinking about how private industry will communicate this information, make the best use of it.
So the question is, how can the private industry, the weather enterprise, for example, use the data or the information more effectively that's produced by NOAA for forecasts, or is that being investigated?
It's not really designed to be broadcast, for example.
So just to clarify, Brian, I think you're referring probably specifically to the new map product, or is it more than, are there other products as well?
Well, it's a volume of data.
Uh-huh.
It isn't consolidated, where it used to be all the information you got was in an advisory,
Mhm.
right? Now it's in a whole set of pieces of data, including the storm surge map, which is all good and important information, but it's not really made to be broadcast. It's made to be understood in volume on the internet.
So I think that, so the follow-up point was, there's a lot of data out there, and it's hard to format that for broadcast media. I understand what you're saying, and I can appreciate that, and I think that's a challenge that we do face on both sides, because it speaks to the increasing importance of people getting their information on the internet. That is an increasing dissemination mechanism. There is an increasing volume of data, and so we also don't, I would say, we want to share what we have, but we also then want to be able to communicate. So one of our goals in developing the new storm surge map was to talk to broadcast media and talk about if they think that is effective, and what their needs are and what those requirements are. I think part of where we need to go is to make some of the data available in formats that would be useful for repackaging and broadcast media, and showing, enabling the private enterprise to use that data in their own formats in ways that can be effective in online broadcasting. For example, making the underlying data within a potential storm surge map product available for remapping, let's say, revisualization. But one of the challenges has been in dissemination pathways. So the Weather Service, I sit in the Ocean Service, so I'm going to speak a little bit about the challenges that the Weather Service face. They rely heavily on robust but bandwidth-constrained operational dissemination mechanisms. And that's one of the issues that I'm sure you're familiar with, and that's currently being addressed in some new technologies that the Weather Service has implemented. Now, that's not all online. Not everything's in a GIS-friendly format yet, but it does need to be part of the strategy for how these new products are being built. I think that, so we're not there yet, but hopefully we can keep chipping away at that.
Yes, over here.
I believe it's a question for Jesse. I'm Catherine Hozek. I cover the Atlantic North Carolina. And one of the things that people there complain about is the lack of a lot of the offshore buoys and the inshore buoys have been destroyed by weather or lost over the years or aged out.
That's really not my area of expertise, the planning and placement of observational platforms. I'm on the modeling side. I agree that having observational data is important, and we do rely heavily on the data that we do get, but it is, they are expensive to put the platforms out there. So, but I can't speak specifically as to any particular observational platform.
Question over here, Nick.
Nick Alman with USGS. I'd like to back up one question. It was made me think of an interesting analogy about, I didn't know that 95% of the weather information the public uses is private. That's fascinating to me. But I'll just use Everglades restoration, where we have a really strong science program, and the science becomes more advanced. We always have a challenge of making that information available and using it for, especially for decision makers. And it seems there's an interesting analogy there, and we're having to really spend a lot of effort on that, and it pays off when we do, such that a lot of times we put the science on the table and walk away from it and expect it to be automatically picked up and used, and it isn't. There's a lot of energy that has to go into making sure that science is in a useful format, it's understood, and it's being used correctly. I don't know if that's a useful analogy for the one about the weather information, but I think that's pretty fascinating.
So the comment was, so I want to comment, maybe Ben, you might want to comment on this in your work. The comment was on the need or the importance of collaborating between scientists and the end users and stakeholders. So I would completely agree with that. In the program that I'm heading up, the Storm Surge Roadmap, we've tried to make progress on that by working with local emergency managers and broadcast media and weather forecasters and bringing them together and along with the general public to understand their needs. So if we're going to make effective use of science, having an integrated team really, I've found in my personal experience, is of growing importance because of the challenges in communication. And I think that's something maybe you guys have focused on as well.
Yeah, I mean, I'll just briefly agree. And even what you just said, Jesse, right? The needs of emergency managers are going to be different than the needs of broadcast media and public. And what emergency managers think the public understands is different from what the public understands and so forth. So there's a lot of work here. And certainly at Climate Central, it's in our culture over the year. We've got half scientists and researchers and half journalists, and there's a lot of work to do there in the translation. I mean, there really is.
Yes.
Just sort of following up on that again, Jan Spiegel from the Mirror, Connecticut. How much are you actually doing that communication with government entities? Because at least my experience there has been that they're giving the cues to the private broadcasters, and the lack of understanding in terms of what storm surge is. And frankly, if I had a nickel for every time someone said to me, "Oh, it's never flooded here before, why should I leave?" I probably wouldn't be here now. Where is, I guess, so it's sort of an extended question in terms of how that communication, if government's tied in, that then trickles down potentially to local broadcasters, local media to get information to people who frankly may not be watching television and may not be on their computers to get the hell out message. I mean, so what's happening there?
So this is Jesse. So the question was how do folks like, I guess I can comment for myself. So the folks like at the federal level work with local entities, local government officials, and local media in terms of getting the message out. Hopefully I summarized that pretty accurately. I think there's a number of factors there, and we've tackled that in a couple different ways in NOAA from a storm surge perspective. One is by working with social scientists and conducting on-the-ground surveys. We've conducted a series of 7 surveys, so phone surveys, focus groups, in-person interviews, all sorts of feedback from areas throughout the country that we're trying to get that on-the-ground feedback. So that's helping us to give us direction and guidance on where we need to go. And then when we're in operations, what really matters is having a local relationship. And so that's heavily within NOAA driven by the local forecast office and the warning coordination meteorologist. That's the person who's actually responsible for that area. So that office generally will know the local authorities and will know the local media, and they need to have those relationships that are built well before an event occurs so that they know who to call up in order to have that communication. So I think some of the challenges that you referred to are related to the complexity of communicating science. It's hard to have communicate a complex local issue like coastal inundation in a way that can be readily understood by everybody out there. So that's one of the reasons why we've rolled out this new product that shows graphically where the water could go and how high it could get, because of the challenges in trying to describe that historically with a paragraph or two or a few sentences in a text product. It's not possible. So now we actually have a picture and make it, in order to make that communication more efficient and effective. So that's one of the ways we've tried to address that issue.
Yes.
Just a little quickie follow-up. You mentioned that you're going to have this.
Could you identify yourself?
Oh, I'm sorry, Linda Marsa Freeman. Anyway, you mentioned you're going to have this storm surge prediction map coming up. Do you have any idea when that will actually be online and operational?
That product is now, sorry. So the question was, when is the new storm surge map going to be available from NOAA? So that product is the potential storm surge flooding map is now experimentally available. It was produced during Hurricane Arthur this year. It started this season. And I have tips for media professionals on that product up here, so you can come and read more about it afterwards. And I brought that as a handout afterwards.
Also available on the web.
Yeah, if you go to the Hurricane Center website and go to their storm surge link or their outreach link, you can get a lot of information about products and beyond this one.
Yes, Matthew Sherman, WNYC Public Radio in New York. About this question, the evacuation decision, it's something that's made by local officials. Is there any thought these are local officials who may never have encountered hurricanes in the past, who don't have the depth of knowledge that you guys have. Is there any thought globally about, well, first of all, is your assessment that actually officials make the right call? And two, if not, is there any thought globally to improve this system so that officials do make the right call in the future?
So the question is, do officials, in dealing with evacuation, do officials make the right call? And is there, have we assessed that? And are there approaches being made to improve that issue? Hopefully I captured that correctly. I can't comment on if the local officials make the right call. Your assessment is accurate. It's the local authorities that make the call, and that varies. Who the authority is varies around the United States. But we haven't assessed that. I couldn't comment on if they do or not. The way that we are trying to make sure that the local official has the correct information is by some of the new the improvements to the way we're communicating coastal inundation, because evacuation decisions in the U.S. are driven by coastal flooding. You may have heard of the phrase, run from the water, hide from the wind. So the evacuation zones are set by the coastal inundation threat, the storm surge threat, and then the National Weather Service wants to communicate to those officials what the potential for coastal flooding is, so that they can determine which zones are going to be impacted and to help inform them make a decision. So I referred earlier to the importance of having those local relationships. Those local officials rely heavily upon the local weather forecast offices in order to communicate information. And that this challenge is one of the reasons why we developed this new mapping product, so that they could see exactly where they're going to go, because they want to know, they want to see where in their area of responsibility what could potentially be impacted, because they were having a hard time without a map in understanding if the water, where the water was going to go, what neighborhoods are going to be impacted, what critical infrastructure and things like that. So we've spoken with representatives from that community in order to develop a product that actually just graphically communicates that to them. So we don't have feedback yet because we've only had one storm on how effective that's been, but that's one of the main ways we're addressing that challenge.
If I could just a follow-up on that. Have you brought people, when you say developing local, when you say that the local weather service
Yeah, the National Weather Service does provide training to local officials on how to make, how to understand the information that's provided by like the National Hurricane Center and how to make decisions about issues like that. You can find information about that on the outreach website of the National Hurricane Center.
We have time for one more question. Yes.
It's a comment on how to get the word out. I don't think it's all that you
Could you
guys.
identify yourself?
My name is Kathy Florsheim. I'm a freelance photographer in Rhode Island, and I'm watching a community that's losing its coastline and no attention to that. I think that's part of the issue, that people know what's going on and have chosen not to pay attention to it. That particular community had people stay in it after Governor J.B. Wiggins' evacuation order in Irene, and I don't think they knew Sandy, but it was against all advice, and they knew it. So it's not all a problem with how you're getting it out. There's a social problem as well, or a cultural problem.
You want to comment on that?
So the question was, or the comment was, in getting people to heed evacuation orders, it's not just if they're getting the information, it's also how they come to the decision of whether or not to evacuate and what the social challenges may be in doing that. I would say, from my personal perspective, that we understand that, and that decision-making during a risk-driven event is complicated, and it depends on a lot of factors that are not pertaining directly to what a federal authority or local authority is saying. There are issues of communication, what you have invested in your neighborhood, how, if you are able to evacuate, things like that. The reason I know that is because of the work I've done with social scientists who are experts in understanding that problem. And NOAA is doing research in collaboration with social scientists to try to understand that issue better. And I think the role that NOAA plays is in communicating clearly about what the risk is. That's really the function that NOAA plays, is to communicate the risk.
It was clear, and there was alcohol involved in not making that decision.
I wasn't on the ground for that.